Hello everyone, I am Assistant Professor Komal Shinde, and today's lecture we are going to discuss about hydrogen spectrum. So basically we all know that white light is made up of 7 visible colors or visible spectrum, and if you pass that white light to the prism, it will separate that 7 colors, and that is nothing but your spectrum. But have you ever think if the light is not white, means if we passing the light to the from the prism is not white, then what happens? Okay, so by heating a gas with the electricity we can get it give off colors. Okay, first we need to heat that gas, then it is giving color, and passing that light through the prism does something different. So here white light is passing through the prism, we are getting a continuous spectrum, and gas which is heated, when it is passing through the prism we will get the absorption and the emission spectrum. So atomic spectrum are nothing but the fingerprints of an atom, because I have told you many times that every element in the periodic table has a unique atomic spectra, like every human being has a unique fingerprints, same like every atom has a unique atomic spectra, means every element I must say. Okay, so each element give off its own characteristics color and can be identify the atoms. So by observing that spectra we can identify which atoms or which elements are present in that particular gas or material. Okay, so hydrogen absorption spectrum is shown, then carbon absorption, hydrogen emission, then carbon emission, then oxygen absorption and oxygen emission, so on. So atomic spectrums are fingerprints of an atom. So these are the line emission spectra of hydrogen, then this is neon, and this one iron. So the light is emitted or given off from this particular gases or elements, we can say hydrogen, neon and iron. So hydrogen spectral lines, we have already seen this formula, means Bohr's calculated the energy, frequency, wave numbers, then spectral emission lines for of a hydrogen atom. So this wave number nu bar is equals to r in bracket n1 square minus n2 square, means here the electrons are making transitions from the higher energy level to lower energy level. In that case we will get the emission spectra. So the wave number of the different spectral lines can be calculated corresponding to the value of n1 and n2. Okay, so Bohr explanation for the hydrogen spectrum: when the current is passed through the hydrogen gas, the discharge tube at a low pressure, the molecules of hydrogen breaks into the atoms. So H2 gas, electric discharge at a low pressure through H atoms, and these atoms absorb the energy from this electric spark. Then the elements of a hydrogen atoms are excited to the higher energy level, means here you can see from the ground state. Okay, we are providing external energy and they are jumping to the higher excited states. The higher energy orbits to which the electrons migrate depends upon the amount of energy absorbed by the electrons, means where it will jump in the first excited state, second excited state, third excited state. It will depend upon the how much amount of energy that particular atoms has absorbed. Okay, so these excited electrons being unstable and come back to the lower energy level. Okay, after spending some time, about 10 to the power of minus 8 second, it is immediately coming down by losing the excess of amount of energy which they have absorbed previously. Okay, and the electrons may come to the lowest energy level. So in this way they emit the energy they had absorbed. So in this figure you can see they have emitted the photon which they have already absorbed, and they are again coming down to the ground state. So this is the setup actually. High voltage, this is the hydrogen gas filled in this tube, then this is high voltage, you have the slit, the beam is passing through the slit, then here you have kept a prism, then here is your photographic plate on which you are actually observing that emission spectrum, and this is actually a hydrogen spectrum. So wave number of a spectral line, different spectral series are produced depending upon the excited and the ground level of the electron. So wave number of these spectral lines can be calculated by the Bohr's equation. Here this R, in this equation this is actually R, that R is nothing but Rydberg constant, meter inverse, it is the unit of wave number. Okay, here you can observe depending upon from where to where electron is making transition, means here is a electron, it is making transition from 3 to 1, then 4 to 2, then 5 to 2, we will get different color, means for 4 to 2 you are getting violet, then for 4 to 2, sorry, 5 to 2 you are getting violet, for 4 to 2 you are getting green, then from 3 to 2 you are getting red. So there are several series for the hydrogen emission spectra. So first one is the Lyman series. The spectral lines in the Lyman series are explained uh, by considering the electron falls back from n1, means it is falling back to n1 from the higher energy levels. Okay, so here n1 is 1 and higher energy level can be 2, 3, 4, 5 and so on. So these are the Lyman series, and Lyman series spectral lines are lie in the ultraviolet region. So here you can observe the wave number, this one, this one, this one. So it is for a Lyman series we are getting ultraviolet region frequencies or wavelengths. Okay, so this is, you can see, 2 to 1, then 3 to 1, means from higher energy level atoms are making transition to the n is equals to 1 level, and in that case you will get the Lyman series. Then for a Balmer series, in this series electrons fall back through the energy level 2 from the higher energy levels, n2 is equals to 3, 2, 4, 5, 6. So for this series you will get a transitions which is lies in the visible region. So for a Balmer series, the first line which you are getting when electron make a transition from 3 to 2 is H alpha line, this one. Next is H beta, next is H gamma, next is H delta and so on. So these frequencies are lies in the visible region. The next series is the Paschen series, and in this series electron is falling back to the energy level 3 from the higher energy levels like 4, 5, 6, 7. Okay, and for this whatever the line spectrum you are getting, that is lie in the infrared region. So here you can easily see that it's a ground state for this Paschen series is 3, and electrons are making transitions from the higher energy levels. Next series is the bracket series. In this series electrons fall back to the energy level 4 from the higher energy level 5, 6, 7, 8 and so on. So here you can see atoms or electrons making transitions from the higher energy levels to the energy level n is equals to 4. For a bracket series also we are getting radiations which are falling in infrared region. The last series is Fun series, and in a Fun series electron is falling back to the energy level 5 from the higher energy level 6, 7, 8 and so on. Okay. For P Fun series also we are getting the radiations which are fall in the IR region. So here it is making transition from higher energy level to n is equals to 5. So these are the series for hydrogen emission spectra, means Lyman series. First one is the Lyman, you should remember the sequence. First one is the Lyman, for that ground state n is equals to 1, means electrons or atoms are making transition from higher energy level to n is equals to 1. Second is the Balmer, it is lies in visible region. Balmer series, this is lie in ultraviolet region. Then Paschen, bracket and P Fun are lying in IR region. Okay, so this is all about hydrogen spectrum, means what we have learned in hydrogen spectrum. If you heat this hydrogen gas and pass that emitted radiation through the prism, you will get a emission spectra on this photographic plate. You are observing color because visible light is means we can see only visible light, that's why on photographic plate you can see this spectrum, but actually hydrogen spectrum emits uh, radiations which lies in ultraviolet region, then visible region and IR region also. So Paschen series, then your bracket series and your Fun series are lie in near and far infrared region, whereas your Balmer series lie in visible region and Lyman series lie in ultraviolet region. So important point of this, you should remember this H alpha, H beta and H gamma, means in the exam they can directly ask you how you what will be the frequency of H alpha line or what will be the wave number of H alpha line, then you should know that H alpha line is the first Balmer series line where electron making transition from 3 to 2. So this is all about hydrogen spectrum. Thank you so much.